Hi everyone, welcome to another maths video by Maths with Sarah. So today we're going to be tackling this question which involves a histogram. Now histograms automatically are just a step harder than any other type of graph question because you're using the area and the frequency density rather than actually the numbers that you can read directly off the graph. So they're already a step more challenging. This one again is definitely one of the harder ones. It comes from paper 3, question 26. It's right at the back of a paper 3. Definitely a challenge. I encourage you, as with all these questions, to have a go yourself. Even if you think you know what to do, you're a little bit off, you've got a bit stuck somewhere, you know the method, but you're not quite sure how to do it. Don't worry, just try your best, give it a try yourself. And check back once you've had a chance to have a look yourself, and I'll go through the whole thing. Okay, so let's get going. So we've got a histogram here that shows information about the speed of cars as they go past the checkpoint. So we haven't got a scale on the frequency density axis, which already makes things complicated. And the histogram shows information about 480 cars. Now that is going to come in quite useful later on. So we've obviously got we've got 3 different bars here. They're all representing the speed of different cars. And obviously, yeah, we can see we've got most of them are traveling between 30 and 35 miles an hour, but there's all sorts of different things going on here. Anyway, what we want to know, the first part of this question is how many cars does the first bar represent? So we need to try and work out how much the first bar represents. And then we've got a follow-up question that asks us about cars that are traveling over a certain speed. So when we're dealing with histograms, we need to do everything based on the area. So the area of each block shows us the number of cars. So because this one here, you can hopefully just by looking at that, you can see that it covers the biggest area. That therefore means that this one has the largest number of cars in this section. And this one's probably second largest and this one's third largest. So even though this one's highest, it doesn't actually mean that that's got the largest number of cars. So if we want to work this out, the way that we can do this is by calculating the area of each one of these bars. So this first one, if we count the number of squares, we've got 5, 10, 15, 20, 25. So this is the same as 25, or the area of this is the same as 25 times by 5, 10, 15. And if we calculate that, that equals 375. We can then do the same for this one, because obviously we need to work out the frequency density, and this is all about ratios. We know that we've got 480 cars, so we need to try and work out from there exactly what we've got here, basically. So if we do this next one, we'll see that the height is 33, and the width is 5. So if we do that calculation, we end up with 165. And again, this is frequency density, not the number of cars. Again, for this bottom one, we can do that as 4 times by 15. So if you read off the axis, you can tell what the area is, and this equals 60. So now, if we add all of these 3 values up, we end up with 375 plus 165 plus 60. And if we do that maths, what we actually end up with is 600. Okay, but rather than having 600 cars, which would be really nice to make the maths very easy, we have instead only got 480 cars. So for each of these, we need to times this value here, or whichever value we've got, the area of the bar, by times it by 480, but then divide it by 600. So if we do that for each of these, we end up with 300. I'm going to do it in a different color actually, so you can see. So the actual number of the cars is, the first bar will be 375 times by 480, because that's the total number of cars that we know we're counting, divided by 600, because 600 is the total area. So basically, we're using that as a fraction. We know that we've got 375 out of 600 blocks are discussing this first bar. So to work out the number of cars, we need to then do that times by 480. And if we do that, we end up with 300. So this one here, This bar represents 300 cars. Now, if you've watched a few of these videos, you're going to realise that I always am a fan of checking that you've got the right answer. So in order to do that, the way that I would do it is to do the calculation for each of these. In theory, you should get a total of 480. So if we do that for the second one, we'll do exactly the same again. We'll do 165 times by 480 divided by 600. And if you do that maths, you end up with 132 for this, representing this central bar. And then again, if we do the same for bar 3, we'll do 60 times by 480 divided by 600. And for that, you end up with 48. And just to double check that you've got your maths right, if you add all three of these up, you do in fact get 480. This is an excellent way of checking that you're at least on the right lines and you've done the maths right. You can't guarantee you've got the right answer, but you can guarantee that the math that you've done is correct. So that's a really good start. We know how many cars the first bar represents. Okay. The second part of this question asks us to estimate the number of cars that are over the speed limit. So the speed limit is 40 miles an hour. Well, that obviously is tricky. So we are looking at the cars that fall into this portion of the graph, which obviously is not a full bar. It's only part of the bar. So we know that the total bar is 60, but we're only looking at a portion of that bar. So the total of the bar is 60 squares, or even 48 cars. Doesn't matter how we think of this. And we're looking at a third of this, two-thirds of this bar. So if we're doing this, if we shade this in, we can see that this portion here, the shaded area, is 2/3 of the total bar. So we can then say, well, okay, this is 2/3 of the total bar out of 48 cars. We know we've got 48 cars in total that represent this bar, but we only want the 2/3 of them that are over the speed limit. So if we do that maths, we're going to end up with 32 cars which are over the speed limit. And that does seem roughly correct. So if we're just thinking about, kind of eyeballing it, yeah, that probably is equal to about 32 cars. We've got 480 in total. It's going to be a pretty small number. We've got it's about just under a tenth of the total, probably roughly in the right ballpark figure. But obviously this is part of the question. The question is asking you to estimate the number of cars. So what often is a follow-up question for this would be, why is it an estimate? So why is it not the exact number? Why is it only an estimate? Well, of course, what we don't know is where each of these cars fall in these brackets. So it could well be, in fact, that out of the 60 cars that make up this area or this bar here, all 60 of them might fall into this speed here. It might be 35 to 40, but for whatever reason, the bracket's been put up to 50. That's highly unlikely, of course. What you'll probably find is that most of the cars in this are doing, you're probably going to end up with some sort of curve around this line. So yeah, you probably end up with, it might not be as evenly distributed. You might not have 32 in this section, 32 in this section, 32 in that section, which is the problem, or a little bit of the problem with histograms, is that you have to estimate the number of cars rather than being able to read it off exactly. Okay, so that's this histogram question. I appreciate, again, it was a little bit of a challenging one. It's not going to be as straightforward because it's right at the end of the paper. It's going to be challenging. You're going to be really pushing those students who are aiming for the grade 8, grade 9. But definitely something that I think is, if you've seen a histogram before and you understand the idea of frequency density and using the area rather than using the height of the bars, you shouldn't have too many problems with this question. I have got a few other graph and statistics questions on my channel, so I'll tag them all in the end of this at the end of this video, but I do encourage you to check them out and subscribe to my channel. Thanks for watching.